Yes, it is important which phase the high leg is connected to on a delta system. Each phase has distinct voltage characteristics, and incorrect wiring can lead to equipment damage. Delta systems adhere to a specific phase sequence, typically ABC or ACB, which determines the voltage differences between phases A and B, B and C and A. The high leg, also known as the wild leg or stinger leg, possesses the highest voltage to neutral. In a 208-volt delta system, the high leg measures approximately 120 volts to neutral. The wires extending from the load side of the relay must connect to the appropriate motor phases to ensure proper operation. Incorrect high leg connections can disrupt motor function. For a 208-volt delta system with an ABC phase sequence, the recommended wiring involves connecting the high leg to phase C. The remaining two wires from the relay should then connect to phases A and B respectively. Incorrectly wiring the high leg can result in several adverse effects, including firstly, reduced motor efficiency, secondly, increased motor temperature, thirdly, premature motor failure, fourthly, potential damage to the relay itself. Consider a scenario where the high leg, intended for phase C, is mistakenly connected to phase A. This misconnection disrupts the voltage balance across the motor windings. Phase A now receives a higher voltage than intended, while phase C receives a lower voltage, potentially leading to overheating and reduced torque. The motor struggles to operate efficiently under these unbalanced conditions. Similarly, if the high leg is connected to phase B, a similar imbalance occurs, with phase B experiencing elevated voltage and phase C experiencing reduced voltage. The consequences remain the same: inefficient operation, increased heat generation, and a heightened risk of motor failure. The relay, responsible for controlling the motor's on and off cycles, can also suffer damage from incorrect wiring. The voltage surge from the misconnected high leg can overload the relay's internal components, leading to premature failure. Furthermore, the reduced motor efficiency translates to increased energy consumption, driving up operating costs. The motor works harder to achieve the same output, drawing more current and wasting energy in the form of heat. In extreme cases, incorrect high leg connections can result in catastrophic motor failure, requiring costly repairs or replacements. The heat generated by the unbalanced voltage can melt the motor's insulation, causing short circuits and complete motor shutdown. Preventing these issues requires careful attention to the phase sequence and proper wiring practices. Always consult the equipment manufacturer's specifications and wiring diagrams before making any connections. Use a voltmeter to verify the voltage between each phase and neutral to ensure that the high leg is correctly identified. Double-check all connections to confirm that they are secure and properly insulated. When working with electrical systems, always prioritize safety. De-energize the circuit before making any connections, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are unsure about any aspect of the wiring process, consult a qualified electrician for assistance. They can provide expert guidance and ensure that the installation is done correctly and safely. In summary, connecting the high leg to the correct phase is crucial for the proper operation and longevity of equipment in a delta system. Ignoring this precaution can lead to reduced efficiency, increased temperatures, premature failures, and costly repairs. By adhering to recommended wiring practices and consulting with qualified professionals, you can avoid these problems and ensure the reliable performance of your electrical systems. Remember to always prioritize safety and seek expert help when needed. A 208-volt delta system, often found in commercial and industrial settings, presents unique challenges due to the presence of the high leg. Unlike a standard 120/240-volt single-phase system, which has a neutral point at the center of the transformer winding, the 208-volt delta system derives its voltage from a three-phase transformer configuration. This configuration results in three phases, each separated by 120 degrees electrically. However, one of these phases, the high leg, exhibits a higher voltage to neutral compared to the other two phases. This difference in voltage arises from the way the transformer windings are interconnected. In a delta configuration, the windings are connected in a closed loop forming a triangle. One of the corners of this triangle is typically grounded. creating the neutral point. The high leg is the phase that is furthest from this grounded corner, resulting in a higher voltage to neutral. Identifying the high leg is crucial for safe and proper wiring. The National Electrical Code, or NEC, requires that the high leg be permanently identified by an orange marking, such as tape or paint. This marking helps electricians quickly distinguish the high leg from the other phases and avoid accidental misconnections. Failure to properly identify and connect the high leg can have serious consequences, including equipment damage, electrical shock, and even fire. When connecting loads to a 208-volt delta system, it is important to understand the voltage requirements of each load. Some loads, such as lighting fixtures and small appliances, are designed to operate on 120 volts. These loads can be connected to either of the two phases that provide 120 volts to neutral. However, these 120-volt loads must never be connected to the high leg, as the higher voltage will damage the equipment. Other loads, such as motors, compressors, and heating elements, are designed to operate on 208 volts. These loads must be connected between two phases, ensuring that they receive the correct voltage. Again, it is crucial to avoid connecting any 208-volt loads to the high leg, as this can lead to overvoltage and equipment failure. In addition to voltage considerations, it is also important to ensure that the load is properly balanced across the three phases. An unbalanced load can cause excessive current flow in one or more phases, leading to overheating and potential damage to the transformer. To balance the load, distribute the single-phase loads as evenly as possible across the three phases. For example, if you have three 120-volt lighting circuits, connect one circuit to each phase. When installing a rooftop unit that utilizes both heating and cooling, it is essential to carefully consider the wiring requirements and ensure that the high leg is properly connected. Consult the unit's wiring diagram and follow the manufacturer's instructions precisely. If you are unsure about any aspect of the wiring process, consult a qualified electrician for assistance. In addition to the high leg, another important consideration when working with delta systems is the phase sequence. The phase sequence refers to the order in which the three phases reach their peak voltage. In a typical delta system, the phase sequence is either ABC or ACB. The phase sequence is important because it determines the direction of rotation of three-phase motors. If the phase sequence is reversed, the motor will rotate in the opposite direction, which can damage the equipment or create a safety hazard. To determine the phase sequence of a delta system, use a phase sequence meter. This meter will indicate the order in which the phases reach their peak voltage. If the phase sequence is incorrect, you can correct it by swapping any two of the phase conductors. However, be sure to de-energize the circuit before making any changes. In conclusion, working with 208-volt delta systems requires careful attention to detail and a thorough understanding of electrical principles. The high leg presents a unique challenge, and it is essential to identify and connect it properly to avoid equipment damage and safety hazards. Always consult the equipment manufacturer's specifications and wiring diagrams, and seek assistance from a qualified electrician if you are unsure about any aspect of the wiring process. Location: Bremerton, Washington indicates a high likelihood of encountering various electrical systems and infrastructure, including delta systems, in commercial and industrial settings. This emphasizes the importance of understanding the specific electrical configurations prevalent in that region and adhering to local electrical codes and regulations. The information provided underscores the critical role of electricians and electrical engineers in ensuring the safe and efficient operation of electrical systems in diverse locations. They are responsible for not only installing and maintaining these systems but also for diagnosing and resolving any issues that may arise. Their expertise is essential for preventing electrical hazards, protecting equipment, and ensuring the reliable delivery of power to homes, businesses, and industries. The complexities of electrical systems necessitate ongoing education and training for electrical professionals. They must stay abreast of the latest technologies, codes, and regulations to maintain their skills and provide the highest level of service. Furthermore, They must possess a strong understanding of safety procedures and protocols to protect themselves and others from electrical hazards. In addition to technical skills, electrical professionals also need strong problem-solving and communication skills. They must be able to diagnose and troubleshoot complex electrical problems and communicate their findings to clients in a clear and concise manner. They must also be able to work effectively with other tradespeople and contractors to ensure that projects are completed safely and efficiently. The demand for skilled electrical professionals is expected to continue to grow in the coming years as the population increases and new technologies are developed. This growth will create numerous opportunities for individuals who are interested in pursuing a career in the electrical field. However, it is important to note that the electrical field is a highly regulated industry. Electrical professionals must obtain the necessary licenses and certifications to work legally. These requirements vary depending on the location and the type of work being performed. In addition to formal education and training, practical experience is also essential for becoming a successful electrical professional. Apprenticeships provide valuable hands-on training under the supervision of experienced electricians. This allows apprentices to develop their skills and learn the intricacies of the trade. The importance of proper wiring and connections in electrical systems cannot be overstated. Poorly wired connections can lead to a variety of problems, including voltage drops, overheating, and even electrical fires. Therefore, it is essential to use high-quality materials and follow proper wiring techniques to ensure that connections are secure and reliable. Regular inspections of electrical systems are also important for identifying and addressing any potential problems. These inspections should be performed by qualified electrical professionals who can identify hazards and recommend corrective actions. In addition to inspections, preventive maintenance can also help to extend the life of electrical systems and prevent costly repairs. This includes tasks such as cleaning electrical panels, tightening connections, and replacing worn or damaged components. The advancements in technology have also had a significant impact on the electrical field. Smart home technology, renewable energy systems, and electric vehicles are just a few examples of the emerging technologies that are transforming the way we use electricity. Electrical professionals must be able to install, maintain, and troubleshoot these new technologies to meet the growing demand for these services. The integration of technology into electrical systems also requires a strong understanding of networking and communication protocols. Smart home devices, for example, often communicate with each other and with the Internet. Electrical professionals must be able to configure and troubleshoot these networks to ensure that the devices function properly. The development of renewable energy systems, such as solar and wind power, has created new opportunities for electrical professionals. These systems require specialized knowledge and skills to install and maintain. Electrical professionals must be able to design and install these systems in accordance with local codes and regulations. The increasing popularity of electric vehicles has also created new opportunities for electrical professionals. Electric vehicles require charging stations, which must be installed by qualified electricians. Electrical professionals must be able to install these charging stations in a safe and efficient manner. The electrical field is a dynamic and challenging industry that offers numerous opportunities for skilled professionals. By staying abreast of the latest technologies, codes, and regulations, electrical professionals can provide valuable services to their clients and contribute to the safe and efficient operation of electrical systems.